Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today we're going to be doing Unit 7, Lesson number 5 on even and odd functions. Now, functions get characterized in many different ways. They get put into these various categories: linear, quadratic, absolute value, etc. And we put them into these categories based on shared characteristics. Today, we're going to look at two very broad categories of functions: even functions and odd functions. Now, some functions are even, some functions are odd, and some functions are neither. All right? So today, we're going to take a look at those that are even and odd. So let's jump in and see what the definition of these two types of functions are. Excuse me. All right, even and odd functions. A function is known as even if f of negative x is equal to f of x for every value of x in the domain of f. A function is known as odd if f of negative x is equal to negative f of x for every value of x in the domain of f. Oh, okay. Well, let's take a look at the first exercise. It's good to be able to read mathematical definitions and theorems. What I found a lot of times was that when I was in college, being able to read math textbooks and really kind of fish through technical language was important. So what I want you to do is I want you to look at those two definitions and then try to interpret what they say. You may even want to substitute various values in for x just to kind of get a feeling for what these definitions even mean. Okay, pause the video now and think about them. All right, I seem to have a frog in my throat today, but we're going to power on through. Well, take a look at the first definition. It says, a function's even if f of negative x is equal to f of x. That would mean things like, f of negative 3 was equal to f of 3, or f of 6 would be equal to f of negative 6, right? So what does that really say? Well, in very simple terms, an even function is one where opposite inputs, which are the x values, give the same output. Opposite inputs give the same output. F of negative 3, f of 3, same. F of 6, f of negative 6, the same. Now, let's take a look at what an odd function is. F of negative x equals negative f of x. So like, f of negative 3 would be negative f of 3. Or f of 6 would be negative f of negative 6. So what does this really say? Well, this really says that opposite inputs, i.e. the x values, give opposite outputs. Opposite inputs give opposite outputs. Y vowels. Let me add that to the other one too. And it's really that simple. So in other words, an even function is one where it doesn't matter whether you put 5 in or negative 5, you get exactly the same y value. On the other hand, odd functions are ones where if I know that f of 7 is negative 2, then f of negative 7 would have to be positive 2. All right? Now granted, not all functions are even or odd. Some of them, many of them, most of them are neither. But even and odd functions play an important role in higher order mathematical analysis. So this course seeks to introduce you to them and kind of get used to the terminology. Pause the video now and write down anything you need to. Okay, I'm going to clear out the text. And let's start to really dig into some even and odd problems. Exercise 2. Consider the partial graph of the function f of x shown twice below. Sketch the other half of the function if in A, f of x is even, and if in B, f of x is odd. The three coordinate pairs are listed to help you plot. So for a minute, I'm going to leave the 0, 0 alone, but let's take a look at the 3, 5. In an even function, opposite inputs will give you the same output. So if 3, 5 is on the graph, negative 3, 5 is on the graph. And if 7, negative 2 is on the graph, negative 7, negative 2 is on the graph. All right. Now what about that point 0, 0? That's a little weird. Well, in an even function, it would say that negative 0, 0 is on the graph. But that's just 0, 0. So that doesn't change much. And it means the graph of our function must look like this. And those are just a few of the points. Of course, we could pick all sorts of points on there. For instance, right here, the point that is about 1, 2 corresponds over here to the point negative 1, 2, right? This point, well, right over here, 1, 2, 3, 4, 5, 6, 6, 0 corresponds to negative 6, 0. So that's an even function. We'll talk about symmetry down here. Let's take a look at the odd. Again, let's leave 0, 0 alone. Let me do this in a different color. Let's go with red on the odd functions. So an odd function would say that opposite inputs give you opposite outputs. So if 3, 5 is on there, 1, 2, 3, 1, 2, 3, 4, 5, then negative 3, negative 5 has to be on there. Likewise, if 7, negative 2 is on there, then negative 7, positive 2. Finally, that weird point 0, 0 again. Well, opposite functions would say that then opposite inputs would give you opposite outputs. But again, that's just the point 0, 0. All right, and there it is. Now, it says describe the symmetry of the even graph and the odd graph. Use as technically correct terminology as you can from your studies in geometry. So let's do that. Let's write down even, and let's write down odd. All right. And now what I'd like you to do is try to describe the symmetry of those two graphs. Pause the video now. Okay, well, assuming you've had geometry, this should be a piece of cake. An even function is symmetric across the y-axis. In other words, right, if I put a mirror right along that y-axis, it would show me this graph. Or, likewise, if I folded this graph across the y-axis, it would land on itself. The symmetry of the odd function, I think, is a little bit more difficult to describe. An odd function is symmetric across the origin. Now, what does that really mean? What that really means is if I took this graph and I spun it 180 degrees about the origin, it would land on itself. Okay? If I spun it 180 degrees. So another way of putting this is that an odd function has 180 degree rotational symmetry about the origin. A lot of people would just prefer to say that it's symmetric across the origin. All right? But you can also describe it in terms of rotations. So take a look at that. Very important work on this page, and then we'll move on and do some more work with even and odd functions. Okay, let's clear it out. So what I'd like to do now is just explore some various functions and try to figure out whether they're even or odd, and also look at that symmetry issue. So let's take a look at the function f of x equals absolute value of x minus 4. It says evaluate this function for a variety of opposite input pairs. Then, what type, even, odd, or neither, does f appear to be? Right? Is it even? Is it odd? Is it neither? Do we know how to use a question mark? There it is. All right, so let's experiment a little bit here. All right, and what I mean by that is let's take some input pairs. Let's go with negative 2 is good. F of negative 2 would be the absolute value of negative 2 minus 4, which would be 2 minus 4, which would be negative 2. On the other hand, f of 2 would be the absolute value of 2 minus 4, which would be 2 minus 4, which is also negative 2. Opposite inputs gave me the same output. Let's do one more pair. Let's do f of, I don't know, let's say 7. Well, that would be absolute value of 7 minus 4, which would be 7 minus 4, which would give me 3. And f of negative 7 would be absolute value of negative 7 minus 4, which would be 7 minus 4, which would also be 3. So the same. So based on these, we're pretty convinced, we know it's not an odd, but pretty convinced that it's an even function. Now, letter B says sketch f of x on the grid below without the use of your calculator. Does it have the correct symmetry for your choice in A? All right, we'll pause the video now and do a quick sketch of this function. You should be able to do a quick but very accurate sketch based on transformations. All right, well, we could generate a table of values, but we're not going to do that. This graph is simply y equals the absolute value of x that's been shifted down 4 units. So we know that the absolute value function looks something like this. So if we shift it down 1, 2, 3, 4, I think we'll just use our line utility, and it's going to look like that. Right. And the answer is yes, it is symmetric across the y-axis. All right, simple enough, symmetric across the y-axis. So even functions are ones that can almost ignore whether the input is negative or positive. And that's kind of nice. Kind of nice, especially when we have more complicated functions, which we're going to run into later in the course, like functions that include trigonometry. Anyway, we'll come back to that. Pause the video now and clear out any text you need to, or write down any text you need to. All right, it's my job to clear out the text, so it's gone. Let's move on to the next exercise. A cubic. Let's investigate g of x equals x cubed minus 4x. We're going to be looking at cubics quite a bit later on in the course, but let's take a look at this one. Letter A says use your calculator's table option to fill in the following table. What type of function is this? Still got problems with question marks, not really sure why. What type of function is this? Explain. All right, pause the video now, put that in y1, and fill out that table of values. Okay, well, for negative 3, what we find is that the output is negative 15. For negative 2, the output is 0. For negative 1, the output is 3. For 0, the output is 0. For 1, the output was negative 3. For 2, the output was 0. And for 3, the output was 15. And look at this. Opposites, right? Negative 15, positive 15. Opposites, 3 and negative 3. And you could even claim these two things are opposites. 0 is the only number that's the opposite of itself, in terms of negative, positive. So it certainly appears that this is an odd function because opposite inputs appear to be giving us opposite outputs. Now take a look at this function in letter B. So you've already got it in y1. Pause the video now, put that window in, and graph it. It's kind of a cool function. All right. Well, again, here comes the graph. It looks something like this. Oh no, I missed. Supposed to go through the origin there, but as usual, my graphing was bad, right? And we've got that symmetry about the origin, right? So in other words, if I rotated that graph 180 degrees, right, if I went like this, it would land on itself. All right, quite cool. Quite cool. All right, pause the video now, write down anything you need to. Okay, gonna clear this all out. All right, one last little problem. Exercise 5. Is the simple exponential function f of x equals 2 to the x odd, even, or neither? Support your argument with numerical evidence. All right, numerical evidence. Well, pause the video now and play around with this. How would you show whether it was odd, even, or neither? All right, well, the key to odd and even is opposite inputs. It's all about opposite inputs. So pick two opposite inputs. Let's go with x equals -2 and x equals 2. So f of -2 will be 2 to the -2, which, as we well know, is 1 over 2 squared, which is 1/4. F of +2 is going to be 2 squared, which would be 4. Now, if this is an even function, these two should be the same. If it's an odd function, these two should be opposites in terms of negative and positive. But these are neither the same nor opposites, so that proves to us that it is neither even nor odd. All right? Pause the video, think about what we just did, and then we'll wrap up this lesson. Okay. So in this lesson, we saw another way that we put functions into categories, and that was by even or odd. Even functions were wonderful. F of -5, f of 5, same output, doesn't matter. Odd functions were kind of nice too. F of 5, f of -5 had opposite outputs. All right, and those are the defining characteristics of even and odd functions. Even function doesn't care whether the input's positive or negative. The odd function does, but gives you exactly the opposite value that the opposite value of x gave you. That didn't come out very articulately. Tongue twisters. All right, for now I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.